Welcome to the second lecture of the day, Balancing Market, Lecture 5B. It will be a bit longer lecture than the previous one on intraday market, so let's see. Again, our main slide about how different markets, how is the sequence of different markets and who clears which market. And now we are talking about balancing market. And it's the TSO in Denmark and again who clears that, not market operator or system operator. Good. So hopefully after this lecture, you will be able to first explain the fundamentals of balancing market. Second, formulate and solve the optimization problem for balancing market clearing. And third, these two words you are hearing for the first time, I suppose, in this course. What are one price balancing scheme and two price balancing scheme? So these two words, one price and two price schemes, I suppose you are hearing for the first time in this course, or maybe, yeah, you are hearing these names for the first time ever. So hopefully you will have a good understanding what they are. Good, and I can tell you that, and again as Danish TSO, they are really pioneering. It's a very leading TSO in Europe in terms of their balancing actions. They are bringing a lot of innovations these days, very exciting innovations. And yeah, they are very fascinating what kind of balancing actions they are taking today. I'm going to talk it more today and also next week when I talk about reserve markets, what kind of new initiatives and again it started. Good. Timeline. Remember, so far we covered day-ahead market and intraday market, IDC. So we discussed that intraday market continues, and also we have 3 auction-based intradays. And now we are here in our H-1. We are pretty close to real time. We are very close to actual time for power delivery. And now the ball is in the hand of TSO. Good. Okay, we learned that you have trades in day-ahead market, intraday markets, IDAs, IDC, everything. But still, the system may have imbalances. Remember that to keep frequency 50 Hertz, we need instantaneous balance between power supply and power demand. So any imbalance will cause deviation from frequency of 50 Hertz, which is the case of Europe, 60 Hertz in the United States. But why still we may have imbalances in the real time or close to real time? Because of, for example, steel forecast errors. Of course, you got updated forecast in the intraday stage. You updated your position, but still you may have forecast error. Hopefully less error than what you had before. Also in close to real time or real time, you still may have failures. Something may happen. The third reason is that also there might be planned imbalances. So in some countries, planning for imbalance is not, it's forbidden. But how can you know that this imbalance that happened, it was on purpose or it was just happened unintentional? How can you know that? So, yeah, so planned imbalances may happen. So also, yeah, I talked to my contact persons in Energinet. Yes, they agree that it may happen. Of course, if it's a significant imbalance, there might be investigation what happened. Imagine that your updated position after day ahead and intraday market is 100 megawatt, but now in real time you say 0. Okay, if it's failure, fine. But if it happens all the times, then you might be suspicious what's happening here. So anyway, planning planned imbalances to do arbitrage between day-ahead intraday markets and imbalance market, balancing market, might be the case. Anyway, for any reason, we may have imbalances. And we need to offset that in the balancing market. Who does that? TSO. Clear? Good. From the TSO perspective, you can say in general there are two types of agents in the balancing market. Those who cause imbalance, who solves the balancing problems. So what is balancing service providers, BSPs? The name is clear, right? They are those who help you to restore the balance of the system. Those who provide the DSO balancing services. So for example, any generation or demand side who is flexible enough and fast enough, capable of adjusting their set point. Set point, it means their position after intraday market. If someone is flexible to adjust that position, that set point, it means that that agent can help us with the balancing the grid. So that one could be a BSP. So, but it cannot gamble that, okay, hopefully in the real time, there will be enough BSPs to help me. So that's why ahead of time, TSO and Eginet books enough capacity of reserve to make sure that they are ready and can be activated. So that's why we also reserve market that I'm going to talk about it next lecture, next week. Is it clear? So who can provide flexibility to us? From generation side, you can think of fast generators, hydro units, gas-fired power units. From demand side, you can think of, I don't know, industrial plants, maybe aggregators, like EV aggregators, like the aggregator of flexible units. Now we have more and more companies in Denmark and in Europe who try to collect, to pool more and more stochastic small flexible units, like heat pumps, like storage, like EVs, electric vehicles, put them together and become like a big flexible asset. They can provide flexibility to the TSO. Or batteries itself, if they are big enough, large enough. Or energy communities. So you can think more and more assets that they can provide this flexibility, this balancing services to the TSO. Okay? On the other hand, we have something called BRP. It's a word in the context of European markets. It stands for balancing service providers. So what is BRP? If you like to participate in any market, sorry, if you have an asset and you like to participate in any energy market or ancillary service market, you have two options. Either you yourself become a BRP, or you find a BRP. What is BRP? BRP is responsible for financial things. So BRP is financially accountable, responsible to the TSO. It means that, let's say that at the same time that you have some wind farms, you are also a BRP. You can go and sign to become a BRP in Denmark or in Norway or wherever. So if you are a BRP, it means that you have wind farms, your day-ahead position and intraday position all together is 10 megawatt, but in real time, what you produce is 9.8. You have 0.2 megawatt of deficit. Now, as a BRP, you are responsible to the TSO to recover expenses of TSO because of the imbalances you caused. Is it clear? If you don't want to be a BRP yourself, go and find a BRP. You can do that. And the BRP could be a bank or financial institute or whatever. The one who can guarantee financially to the TSO that they will cover expenses of the TSO because of the imbalances you cause. So BSPs are paid for balancing services, and BRPs are charged for imbalances caused. Which imbalances? The imbalances that the clients of the BRP cause. This is the definition of BRP that I got it from an Eginet website. So please read it for a minute. So an Eginet's definition is BRPs buy and sell electricity on power exchanges on behalf of suppliers and facility owners. So facility owners could be themselves a BRP. Every day, BRPs submit plans to an Eginet on the volume of electricity expected to be generated and or consumed in the next 24 hours. Then here, BRPs are financially accountable to an Eginet or any other TSO for imbalances between expected and actual generation or consumption on the day of operation. Okay? So for example, your position after in H-1 is the expected, the plan, the schedule is to produce 10 megawatt, but the realization is not 10, it's 9.8. Then BRP is responsible. The BRP of that wind farm. Actually, it's impossible to predict the day's generation and consumption 100% accurately. Any imbalance will be balanced out by an Eginet. So an Eginet will offset the imbalance. And then BRP are invoiced the price of the respective imbalance that they caused. Is it clear? Good. So if you create imbalance, you will receive an invoice through your BRP. That's the whole story. Good. So there are two ways that we may have imbalance in the system. One case, more common case maybe, is that the system has a power deficit. It means that supply is less than demand. It means that if that happened, frequency will go below the nominal frequency, for example, 50 hertz. If that happens, and when it happens, for example, there is a failure of a generation, or maybe there is underproduction by renewables, then what we need is upward regulation. So then BSPs, those who provide us balancing services, they should provide us upward regulation. For example, in case of generators, it means increased production. Or in case of demands, if demands are BSPs, it means reducing their consumption. Is it clear? The other case that may happen is that the system may have power excess. It means that the supply at that moment is more than demand. And if that happens, the frequency will go above the nominal frequency of 50 hertz. In that case, what we need, what TSO needs, is downward regulation. For example, if you are a generation side BSP, you can reduce your production. Or if you are in the demand side flexibility provider, you can increase your consumption. Is it clear? Good. So, a full overview of how an Eginet or TSO sees the imbalance management. As I said, and I'm going to talk more next week, on D-1, way before day-ahead market, I think it's like 7 a.m., 8 a.m., something like that. I have to check the exact time. I'll have it ready for next week. we have something called ancillary service markets or reserve markets. Then the TSO procures various ancillary services. So just I'm giving you a heads up, there are different types of reserves in terms of how fast they are in responding. MFRR, AFRR, blah, blah. I'll talk about that next lecture. So the TSO buys from BSPs, balancing service providers, different services, reserve services, for each hour H of day D for the next day, including a specific service called Frequency Restoration Reserve, FRR. Next week you will see that there are two types of that, manual FRR and automatic, MFRR, AFRR. You will learn more of that. But what you need to know at the moment is that at some point, D-1, before day ahead market, TSO books some BSPs to provide up regulation and down regulation. And of course, here you pay those people. We're going to talk about that next week. So based on this reserve market, for example, you book a gas-fired power plant by 1 megawatt, not megawatt hour, 1 megawatt. For example, for upward regulation. So it means that if, for example, I don't know, a capacity of a unit is 10 megawatt, if you book 1 megawatt of that unit for upward regulation, it means that that unit can only bid 9 megawatt in the day-ahead market because 1 megawatt of that has been allocated for upward regulation. So for example, if this is the capacity of a generator, 10 megawatt, you say that, okay, 1 megawatt, I booked it for reserve, upward reserve. That's the only capacity left for you to go and bid in energy market like day-ahead market. Clear? Good. So then say that in the reserve market, that bid has been accepted. So we have 1 megawatt booked from that generator. So now this generator, in the 5 p.m. on D-1, it should submit its activation price. So saying that if you activate me, my activation price will be, for example, 30 euro per megawatt hour. It means that if I produce extra, because it's for upward regulation, you have to pay me 30. It might be different than the day-ahead market. For example, imagine this generator already sold this 9 megawatt at the price of, I don't know, 25 euro in day-ahead market. It may happen that the generator offers a higher price than the day-ahead market for upward. So it's a very interesting question what the activation price should be. I mean, for the case of, I don't know, gas-fired power plant, you can still argue that the activation price is the fuel price. Maybe a bit more than day-ahead price for some reasons. But for example, if you have a battery or if you have a portfolio of electric vehicles or heat pumps, how can you calculate your activation price? You don't have a clear fuel. I mean, there is no fuel for example, a battery. So what will be your activation price? It's a tough problem, right? Any idea? That activation price can be, for example, based on opportunity cost. Have you heard of that name, opportunity cost? For example, if you ask, I don't know, electric vehicle aggregators to provide you services, it means that at some point of time, EVs should not be charged and we shift it to another time. Maybe this caused some cost, some opportunity cost. Anyway, that's the BSP's problem, how they should come up with their activation price. But they submit it at the first activation price should be submitted until 5 p.m. Then until 25 minutes ahead of time, BSPs, they have a chance to update their activation price. Is it clear? So for example, if the gas unit said my activation price is 30 euro, until 25 minutes ahead of the real time, they can update it. Maybe they update it to, I don't know, 32 euro per megawatt hour. And then in 25 minutes ahead of time, the activation price is fixed. In Denmark and I suppose everywhere, we also have voluntary bids. What is voluntary bids? If you are a BSP who didn't submit your flexibility in the reserve market, so you haven't been paid at all there, still you have a chance to bid voluntarily by submitting your reserve quantity and your activation price. For example, for any reason, you didn't bid something in the reserve market a day before, but now you know that you have flexibility until 25 minutes ahead of time. You tell TSO, oh, by the way, I can increase my production by up to 1 megawatt at the price of something like 40 euro per megawatt hour. We call it voluntary bid because we haven't booked it before in the reserve market. But if you have an allocation in the reserve market, you are obliged to submit activation price. But there is no application for voluntary bids. Are you following me? Good. So now we are in the real time. We are in the last hour. And what happens? Energinet received all activation prices from everyone, including those who has been booked in reserve market and those of the voluntary bids. We have activation price from everyone. So what TSO does is start activating people based on their price, activation price. So if you need upward reserve, you will start activating people from the cheapest to the most expensive generators or flexibility providers. If you need downward reserve, downward regulation, it means that people, if the generator, producing less. If it's demand, consuming more. You are going to start activating people with the highest activation price because they have to pay to the TSO. Is it clear? So it's based on the merit order. And of course, the last BSP activated, its activation price sets the balancing price. Is it clear? And I'm going to have more examples. And by the way, balancing market granularity is also going to be changed to 50 minutes. So what I told you is that the activation price of the last BSP activated sets the balancing price. It is the case today, but soon, very soon, it will be changed. I don't want to now add more complexity to the course, but if you are interested, you can read that one. A very, like a teaser is that what I told you is based on the activation of MFRR reserve providers, but soon it will account for both activation of manual and automatic reserve providers, MFRR and AFRR. I'll tell a bit more next week, but yeah, just have it there. Good. Example. So this is the offers of these 4 agents in the day-ahead market. We already had that. Let's assume that there is no intraday market for simplicity. So it means that in the day-ahead market, the 90 megawatt of demand will be supplied by wind, 20 megawatt, 50 megawatt by G1. So the remaining 20 megawatt by G2. And the market price is 30 euro per megawatt hour. That's the day-ahead schedule. Now imagine that in the real time, in the balancing stage, we realize that G1 is out for any reason, for any failure. It means that the system imbalance at the moment is plus 50 megawatt. It means that the system, an egg unit, needs to activate 50 megawatt of upward regulation. For example, G2, who has a capacity of 100 and already scheduled for 20, can increase its production to 70. Example 2. Imagine the wind farm who is scheduled in day-ahead market by 20 megawatt, now says that, oh, my forecast was wrong, was very, how to say, pessimistic way, and now I'm generating 35, 50 megawatt more. And then system imbalance, because of the wind farm, is minus 15. It means that we need downward regulation. If we want to attract, absorb all wind farm, we have to ask someone, a generator, for example, G2, to reduce by 15 megawatt. Or demand, maybe increase the consumption by 15 megawatt. Example 3 could be the combination of example 1 and 2. If that happens, then the imbalance is 35, requiring upward regulation, because we have 50 megawatt deficit plus 15 surplus, so in total 35 deficit. Is it clear? And if this happens, now I'm introducing something called positive imbalance. Later I'll call it more desired imbalance. What is that? Here the imbalance of wind farm is desired. Why? Because it's unplanned imbalance, but it's helping the system. What I'm saying is that we have 50 megawatt deficit while we have 50 megawatt surplus. So this is because of G1. This is because of wind farm. Overall, we have 30 megawatt deficit. So here, the 50 megawatt surplus of wind, it's positive imbalance. It's a desired, it's helpful. Although it's unplanned, but it's helping the system. Are you following me? It's important in your COUT quizzes. So there are some imbalances that they are helping the system. Some imbalances, they are not helping system. Actually, they are the reason why we have problem. Good. Also, you can think of very extreme actions if you don't have enough reserves. For example, if you need upward regulation and you don't have any sufficient balancing resources, you can cut demand in a voluntarily way. We call it curtailment or load shedding, and of course, it causes a significant penalty for the TSO. Or if you have a lot of extra wind power and you don't have enough downward resources, you have to spill that wind power. Again, it's not something that we like it. So we call curtailment and spillage as extreme actions, if necessary. Good. Let's get back to our example. Remember, the market price in day-ahead is 30. So the question is that, imagine G2 and D1, they are rational. Now they want to submit their downward regulation. Downward regulation means that G2 should produce more or demand, G2 should reduce the production or demand consume more. If you are G2 owner, are you going to submit your activation price at a price higher than 30 or lower? Yes? Lower. Because when as a G2 you provide down regulation, it means that you reduce your generation, you have to pay it back. So what I'm saying is that G2 already paid at price 30 euro per megawatt hour times 20 megawatt. It's already paid in the day-ahead market. Now we are asking G2 produce 20, but for example, produce 15. So 5 megawatt less. So for the 5 megawatt less, it should pay it back because the actual production will be 15, not 20. So of course, if you are a profit maximizer, you are going to say that, okay, my activation price is less than 30. For example, it's 20. So it means that for the 5 megawatt that G2 will never produce, it's going to earn 3 euros. The same for demand. So when you are in a downward regulation phase, you are going to bid at a price lower than day-ahead price. Good. For the upward, it's opposite. So you already produces 20 megawatt. Now you are bidding upward regulation to produce more. So your final production will be 25. Then you will bid at least at the price of day-ahead market or more, maybe 33. So for upward regulation, usually the activation price is higher than the day-ahead price. That's why the activation price, the first starts at 5 p.m. after day-ahead market. Good. By the way, for G2, what is the maximum upward and downward it can provide? Remember, its day-ahead schedule is 20. So this is G2. The capacity is 100, and already the day-ahead schedule is 20. How much you can increase and how much you can decrease your production? You can decrease your production, downward regulation, up to 20 megawatt. And you can increase your production up to 100. So it's 80 megawatt. Clear? So 20 megawatt is the maximum quantity that you can bid as downward regulation, and 80 is what you can bid maximum for upward regulation. Is it clear? So as a TSO, you have to always be careful because if, for example, you don't book G2 at all in the day-ahead market, then the downward regulation it can provide is 0. Okay? Now opposite, what about D1? D1, the day-ahead schedule of D1 is 90. And that's its maximum consumption. Downward regulation means that the demand consumes more. Is there any capacity for demand to consume more? No. So downward capacity of demand is 0. How much upward regulation it can provide? Hypothetically 90. So again, what you have to make sure as a TSO is that if you fully dispatch a demand, it will not be able to provide downward regulation. Downward regulation. Good. Again, the balancing market is based on auctions. So, in the right-hand side of this table, you have your upward resources. G2 can provide you upward regulation up to 80 megawatt. Imagine that G2 already voluntarily or in the reserve market already bid 80 megawatt for upward regulation. So 80. And imagine that G2 offers upward regulation at a price higher than day-ahead market, which is 30. Imagine it's bidding at price, the activation price is 33. That's input to the TSO. Then demand is 90 megawatt, can provide upward regulation by 90. Imagine that D1, as a voluntarily bidder or whatever, says that, okay, up to 30 megawatt, you can curtail me, but then you have to pay me 40. But imagine the rest of 60 megawatt of demand, if you cut it, demand is not happy. It's involuntarily curtailment, and then you have to pay demand, at a very high price like 500. And in reality, it's about 1,000 or 10,000 euros. On the other hand, the only one who can provide you downward regulation here is G2, because imagine G1 is fully inflexible. Let's say that only G1 is already fully, yeah. So G2, imagine, is the only one who is providing you downward regulation. And it can provide you downward regulation up to 20 megawatt, the schedule of G2 in the day-ahead market. And imagine it bids at price 22, less than day-ahead price. Is it clear? So 22, 33, and 40, they are activation prices. And imagine, as I said, your balancing need is 35 megawatt upward regulation. So it means that G2 is enough to offset your imbalance. And then the price will be 33. The balancing price will be 33. And since the system requires upward regulation, the price 33 is higher than day-ahead price of 30. If balancing need is just because of the surplus of the wind farm, if the balancing need is minus 15, the system requires downward regulation, and then the balancing price is just 22, less than day-ahead price. Then we are going to pay wind farm for its production at price 22, less than at the price in the day-ahead market. And a very hypothetical case, if there is no imbalance at all, zero, then the balancing price is any price between 22 and 33, but no one will be paid or charged because there is no imbalance at all. Good. So takeaway so far is that if the balancing need is positive, it means that we need upward regulation, and then the balancing price will be higher than day-ahead price, or at least equal. And if the balancing need is negative, it means that we have surplus, downward regulation is needed, then the balancing price is less than day-ahead price. Very good. So this is what you need for your assignment, optimization problem. Optimization problem for clearing balancing market. Of course, I told you that the last flexible resource, balancing resource activated sets the price. And actually, this is what the optimization problem does. Can you check the optimization problem for a minute? And then we can discuss it together. Yes, please.
Okay. So the objective function is to minimize the generation costs.
Generation cost, okay.
And
but also there are demands there.
Yeah, and also the demand upward regulation or curtailment.
Can we call objective functions to minimize balancing cost? The cost for balancing resources. Okay?
And we have as variables the upward regulation of G2 and the down regulation of G2 with their respective prices.
Very good.
And also we have the up regulation for the demand with a respective price, and the curtailment, which is with a higher cost.
Very good.
The first constraint is the power balance, the balancing market.
Okay, this is the balancing constraint, okay.
And the rest of the constraints are just capacity limits.
Right. Fantastic. Remember, we assume that G1 is fully inflexible, so that's why G1 is not in this picture. So objective function is minimizing the balancing cost. The first three terms, let me come here. The first three terms, they are the total cost of upward regulation. It means that you either ask G2 to produce more, or you ask D1 to consume less, or you curtail demand. And this 33, 40, and 500 is the corresponding activation price. In this case, if those resources are activated, as a TSO, you have to pay them. But here it's the case for downward regulations. That's why you have downward arrow. And here G2 will produce less, so G2 should pay it back to the system because we already paid G2 in the day-ahead market. So remember, G2 is already paid at price 30 in day-ahead market. Now if we ask G2 to produce less, it should pay it back to the system at price 22. So G2 is winning because already we paid it at price 30. Now it's not producing and paying back. Not all 30, but just 22. And it's minus because it's G2 paying back. Is it clear? So that's the objective function. And then we say that G2 upward, D1 upward, and curtailment, they are all upward regulation resources, while G2 down is downward regulation. And together, it's 35. Why 35? Because we said our system right now needs a balancing of 35 upward regulation. You can make it positive or negative. And since the lower bound of everyone is 0, it means that if it's positive, G2 down will take just value of 0, and the others will take values non-zero. So the first cheaper resource is G2 at the price of 33. If it's not enough, then we will go to the other resources. And then, as you said, the other 4 constraints, they limit how much flexibility they have. Is it clear? Yes?
Could PG2 with the arrow upwards and PG2 with the arrow downwards, what if they're both positive? What is that?
It's not going to happen because you are. That's a good question. Is it possible that PG2 up and down both takes non-zero values at the same time? No, because they have different weights, 33 and 22. Right? If it was 33 for both, yes. But it's not going to happen. It's an optimization problem.
Constraints, is that limited, right? There are 2 different variables.
Also constraints, yes.
There they could both be positive, right?
No, optimization will not do that.
It's going to maximize the G2.
It is a diffeasible space, but since you are minimizing the cost, G2 up and down will not take non-zero values at the same time. It is the feasible point, but since it has different weights, both will not get non-zero values at the same time. Clear?
But then it's just from the balancing constraints.
Yeah.
It has to be 35, right?
Yeah.
PG2.
So our PG2 will be 35 because it can go up to 80. So PG2 will take 35, 0, 0, 0. Okay. And of course, the dual variable gives you the balancing price. If you write it in a generic form, you are minimizing your resources for upward and downward. So the total upward minus total downward, it's equal to the imbalance you have. So delta P is input. Dual variable gives you price. And then you have constraints for up and down of every agent, every balancing resource I. Is it clear? Are you following? Very good. So, hope you are ready. You are focused for the next 15 minutes to learn about one price and two price schemes. It's very important. So as I said, this is the day-ahead market outcomes. W120, G150, G220, demand 90, and the price is 30, which is the offer price of G2. Imagine that G1 is out, and wind farm producing 15 extra, so the deficit is 35. That's the example we had before. So here we are. The balancing price is 33. As I said, the balancing price is 33. The system needs upward regulation. Let's calculate payments. Now in the balancing stage, G2 produces 35 extra, receives or is paid at price 33, so G2 gets 1,155 in the balancing stage. Then G1 and W1, they are those who cause imbalance. Now G1 is not producing 50 anymore, so we charge it at price 33, 1,650 euro. That's what G1 should pay. W1 luckily produced extra. We have to pay it because W1 is producing extra. At what price? So that's what W1 receiving. 50 times 33, 495. And it is budget balance. It means that 1,650 that we charge G1, it's enough to pay W1 and G2. Remember, W1 is a desired imbalance. It's not planned, but helping us. That's the total payment in the day ahead and balancing. G2, let's start with G1. G1 already paid at price 30, now should pay it back at price 33, so now G1 is in loss. G2 already produced 20 in the day-ahead market at price 30, now producing 35 extra, so 55 in total at price 33. W1 already paid at price 30 for the 20 in the day-ahead market, and now for extra 15, which is imbalance, now Wind is super happy because for that it gets at price 33, which is even higher than day-ahead price. And the demand, okay, it's paid, it's charged what it's charged in the day-ahead market, 90 times 30. So the first thing, two remarks. The first thing is that here we have budget balance. 1,650 is enough to pay W1 and G2. Good. We are happy. So I like to challenge you. W1 is super happy. W1 caused imbalance. In general, imbalance is not good. But luckily, that imbalance helps the system. And now W1 is being paid at a price even higher than day-ahead price. Do you see a problem here? You are a wind farm. You caused imbalance, 15 megawatt. And not only you are not penalized, but also you are rewarded for your imbalance. Yes?
You can have the incentive of not beating all your forecasts.
Yes. You see, the problem is that there is a big if. If wind farm already expects that the system will be in deficit, it's a big if, then wind farm will not bid truthfully the old 35 megawatt in the day-ahead market because it knows that later the price will be higher. You see what I'm saying? But there is a big if it knows that price later will be more. And if you know that, and if you are fully risk-seeking, risky person, then you will put 0 megawatt in the day-ahead market, and you will bid whatever you have as a wind farm forecast in the balancing market because you know that you are going to help the system. You see what's the problem? So there is incentive for people to not offer their true capacity, their true forecast in the day-ahead market if they know that later the price will be higher. There is incentive, right? Do you see any way to kill that incentive? How can you kill incentive to W1? To cause imbalance because there is imbalance, not because the price is higher. But the wind farm is helping you. Why you are penalizing it?
Yeah, in this case it helps, but if it causes damage.
Yeah, if it causes bad. Now you are penalizing G1 very seriously here. G1 should pay it back at price 33. Good. So how you should deal with wind farm, not G1, because wind farm causes imbalance that help you, desired imbalance. How to deal with that? Bet?
Day-ahead market prices.
If you bid wind farm at day-ahead price, not less, not more, day-ahead price, and day-ahead price is 30. So if you pay wind farm not at price 33, but at price 30, the same as day-ahead price, what will happen? Yes? You remove incentive. You are saying that you helped me, thank you, but I'm not going to pay you more than your day-ahead price. If you are not helping me, I'm going to charge you. But you are helping me, but remember, you're also causing imbalance. It's not balancing service provider. Here, W1 is the one who caused imbalance. Luckily, he's helping. Okay, but to not have extra incentives, we pay it at price day-ahead market. Are you following me? This is exactly about one price and two price. So when you change the balancing price to be day-ahead price, it's two price. When you keep balancing price to what it is, it's one price. Let me go a bit quickly. Imagine day-ahead price is 30, and your wind farm, your scheduling day-ahead market is 25. In the balancing stage, you can see 4 cases, not more than that. The power system, not you are the wind farm owner. The power system either has a deficit or excess. You don't know it in advance. Just it will happen. Maybe you can guess it. Who knows? But you as a wind farm owner, you may produce more than 25, which is your day-ahead forecast, and here we assume there is no intraday, or you are going to produce less. You are going to either produce more or less. Is it clear? There are 4 cases that you can envision. In both cases that you produce more, you should be paid. At what price? We are going to discuss that. But as long as you produce more, you will be paid. In these 2 cases, you produce less than what you scheduled. So you will be charged. At what price? We are going to discuss. So, tell me, here you have power deficit in the system. The balancing price will be higher than 30 or less than. When the power system has deficit, TSO needs upregulation. So the balancing price is higher than 30 or less than? Higher. Here, lower. So, exactly as you said, for example, imagine that when you have power deficit, the balancing price is either 33 when you have power deficit, or if you have power excess, is less than 30, for example, 27. Look at this case. Exactly what we discussed. System has deficit, you are producing more, you are helping the system. Exactly what we discussed. Now you have incentives to withhold. So if we keep this, there's incentives that you withhold, your capacity. If you knew in advance that the system will be in power deficit mode. As I said, it's a strong if. So how to remove this? Exactly what Ben said. We say, market says 33, sorry. Not 33, I make it 30. It's an intervention in the market. Market pays wind farm at price 33. But I veto market and say, no. I'm not going to pay it at 33. I'm going to pay that price 30. It's intervention. It's against free market rules. The same here. The system has excess, but luckily, wind farm produces less. It helps the system. Now, wind farm already paid at price 30. Now, it's going to pay it back us at price 27. So for the imbalance it causes, it's earning money of 3 euro per megawatt hour. Again, we should kill that incentive. Or one may argue that. How? We say, no. We are not charging you at price 27. Though balancing price is 27, we are charging you at price 30 because that's the price you were paid in the day-ahead market. You follow me? So, under two price, in two cases that you are helping the system, luckily, desired imbalance, we say we veto market price and we set market price to the day-ahead price, which is 30. Now look, in power deficit mode, depending you are helping or not, the balancing price might be 30 or 33, two prices. We call it two prices. In power excess mode, depending you are helping the system or not, the balancing price might be 30 or 27, two prices. We call it two-price balancing scheme. Is it clear? So, again, when we say 30, it's intervention. It's not good for the market. You rule out the market. Summarizing. If you are a producer like wind farm who cause imbalance, not provide balancing services, you cause imbalance. System might have deficit or excess. You may have generation deficit, excess, deficit, excess. Remember, in these two cases, your imbalance is undesired. System has deficit. You have generation deficit, so you are part of the problem. So your imbalance is undesired. System has deficit. You have excess. Luckily, you are helping the system. Desired imbalance. System has excess. You have deficit. Luckily, you are helping the system. Desired imbalance. System has excess. You have excess. So undesired, you are part of the problems the system has. The summary is that under one price, we say power deficit, so balancing price is higher than day-ahead price, no matter you are helping or not. So if you have deficit, we charge you at a price higher than day-ahead price. You are producing extra, we pay you at a price higher than day-ahead market. So here you are very happy, you are very lucky. You cause imbalance and you are being paid more. Power excess, the balancing price is less than day-ahead price. You have deficit, we charge you at a price less than day-ahead market, so you are really happy, you are very lucky. If system has excess and you produce extra, you paid at a price lower than day-ahead market. Under two price, we say that whenever your imbalance is desired, we kill your incentive and we make these inequalities equal to the day-ahead price. But as I said, then people, depending they are helping or not, they see two different balancing prices. That's two-price scheme. Clear? This is market intervention. You see it the same for demand. Also demands, either you cause imbalance and it's desired or not, you exactly have the same situation. Clear? Denmark and most of European countries, they used to have two price scheme to kill incentive. And again, Danish TSO switched to one price in November 2021. It means that now you can gamble. If you have a wind farm, you can gamble. If you help the system, you will be very happy. If you are not helping the system, you will not be happy. Gambling. Can you forecast tomorrow at our 3 p.m. what the system status will be? Not yours, the system status. Who knows? But why, it's like an EU legislation asking European TSOs to move to one price. Why? Because two price is a market intervention. Instead, we say that if we have more and more balancing resources in the system, then the price will be closer to the day-ahead price. That's the argumentation. Also, I will tell you next week, and again, it keeps one price scheme, but has an innovation called full cost balancing. And then also it will cause people to think twice when they want to cause imbalance in a planned way. What is that? I'm going to tell you. So it's going to kill a bit the incentives to do that gambling. So Denmark, most of European countries, one price. If I'm not wrong, I think France is still using two price scheme, but that's the only country I heard of. And maybe I'm wrong. Maybe also they're changing. So the last slide. If you want to find historical balancing data in terms of imbalance and price, balancing price, and again, it is very good in providing data. So you can use these two links. The first one, it's amazing. You can see real-time imbalance data live, 1 minute resolution in that link in Denmark. And the second one, you can see balancing prices. Ready for Kahoot? Cool. Again, 10 quizzes. Yeah, Christian online asked, if it's two price scheme, what happens to the budget imbalance? Yes, there will be budget imbalance, but in the favor of TSO. So TSO will get some money extra and can use it the same as congestion rent for grid expansion or whatever. So TSO will not lose. TSO will earn money under two price scheme. So Christian, good question. So let's see who's going to win the second Kahoot of the day. So we have 79 people in Kahoot, either alone or in groups. 80. 81. Okay, it looks stable, so let's get started. First quiz. Who clears the balancing market? Wow. Very high speed. TSOs, like Energinet. TSOs clear balancing market. So Catherine was very fast in responding. Quiz number 2. What's the role of BRP? Yes, BRP, not BSP. So BRPs are financially accountable to the TSOs for imbalances caused by their clients. That's what we saw in Eriginet's definition. So red is definitely wrong. BRPs are not clearing the market. It's TSO. Providing balancing services to TSO, yellow, it's BSPs, balancing service providers, not BRPs. And definitely green is wrong. So now Alex is leading. Quiz 3. Which one is incorrect? Very good. Green is wrong. Red is correct. Resources in the reserve market, if they are allocated D-1, they must submit their activation price until 5 p.m. D-1. They have to do that. It's obligation. Blue is correct. They can update their activation price until 25 minutes ahead of the time, ahead of real time. Yellow is correct. Activation prices determine imbalance price. Actually, the most expensive resource activated, its activation price is equal to the balancing price. Voluntary bids are not accepted. It's wrong. They are accepted. They can beat their reserve quantity and activation price at any time until 25 minutes ahead of the real time. So green is incorrect. Uplink is leading. Quiz 4. Yes, the majority found the correct answer, blue. Under power deficit in the system, we need upward regulation, and the balancing price is expected to be higher than day-ahead price. When system has power excess, the system in the balancing stage, the TSO, activates downward regulation resources, and usually the balancing price is lower than the day-ahead price. Matthew is leading now. Quiz 5. Multi-select. So multiple choices might be correct. So which one or ones are correct for one price? Very good. The majority found the correct statements. Red is correct. In one price, no matter your imbalance is helpful or not, it's desired or not, you will get the same price. Blue is correct. In Denmark and most of European countries, they switch to one price. Yellow is wrong because one price, there is no intervention. There's one price. There is no market intervention there. And green is wrong. It doesn't remove. It doesn't remove the incentive to overbid or underbid. Uplink is back to the first stage. So, multi-select again, the same question, but for two price. Good. I'm happy that the majority found the correct answers. Red is correct. I changed the choices with respect to the previous question. So depending on the system status, one may face different imbalance prices. Yes, correct, under two price scheme. Blue is of course wrong. Now most of the countries, they use one price scheme. Both yellow and green, they are the same as the previous question, and they are valid for two price balancing scheme. Alex is now leading. Okay, 4 questions left, and all of them, they are one price and two price schemes, and the prices under those schemes. So 4 questions very similar to each other. Very good. Day-ahead price is 20. Balancing price is 25. Under one price, balancing price is 25, done. So we are going to pay wind farm for extra at price 25. No matter it helps or not, it's one price. Let's see about two price. The balancing price is higher than day ahead. It means that the system has deficit. While as a wind farm, you produce extra. So you help the system. It's a desired imbalance. But to kill the incentive, you pay wind farm at price equal to day-ahead price, so 20. So that's why red is correct. Under one price, you pay it at price 25. Under two price scheme, you remove the incentive by paying it at price 20. Now Enya is leading. Wow, okay. Not the majority find the right answer. Here, the imbalance is not desired, it's undesired. Your imbalance is part of the system problem. Why? Wind farm produces extra. The balancing price 17 is less than day ahead. Also, system has power excess. So the wind imbalance is part of the system problem. Undesired imbalance. So it's extra, so you are going to pay the wind farm. In one price scheme, 17. In two price scheme, also 17. Because you are not helping the system. Undesired imbalance. So now Ben is back. Quiz 9. Now wind is producing less than scheduled. Very good. Majority found. Again, I'm repeating. Under one price scheme, the price is the same as balancing price. You don't check anything else. So under one price scheme, balancing price is 17, so the price is 17, done. Wind farm produce less. Wind farm has a deficit, so it should be charged. So the balancing price is 17, which is less than day-ahead price of 20. So the system has excess. And on the other hand, wind farm has a deficit, so it helps the system. But we should not let wind farm to be charged at the same price of 17 if we like to kill the motivation. So we charge, because here the imbalance is desired. So to kill the incentive, we charge wind farm at price 20 under two price scheme. So red is correct. Now, Enya is back. And the last question. Very good. The majority found the right answer. Here, system has deficit because balancing price is higher than day-ahead price. And also wind farm has deficit. So wind farm is not helping the system. It's an undesired imbalance. So that's why in both cases, 1 and 2 price schemes, we charge wind farm at the same price of €25 per megawatt hour. And let's see the winner. Mike, number 3rd. Willie Boy, 2nd. Enya from EPFL, I think. I guess it's the 3rd time Enya is winning. So congratulations, Enya.